In this video, we will learn how to create top-down controller for your player. So when you will be holding or clicking on the position on the map with the left mouse click or holding the left mouse button, you will be moving to the target position, and also you will be rotating to the target position. And when you will be holding the shift key, you will be stopping and only rotating to the mouse position. So that's for this video. Let's get into it. To get the starting project, go to description of the video, click Get a Project, download and unzip the file, open Unity Hub, click Add Project and select the unzip folder, open it. In the project view, select Scenes, double-click Sample Scene. Now you are ready for the video. Before we'll start implementing player controller, let's get familiar with our player. So here in the left side on the hierarchy, select the player. You can double click it to zoom in. And let's see what we have on the right side. So what components we are using. We have here animator to animate the movement, and we have here character controller. Character controller will be using instead of the rigid body because we don't want to use physics. Okay, so when you don't want to use physics, you would usually use character controller. Okay. Animator we have for animations. When you will start playing the game, and when you click here play, you will see you will go into the default animation, which is idle. Alright, we are in idle animation, and one other thing is that the camera is following the player. We cannot move really right now, but how we can move the player? I can make this bigger. We can go to the screen view or scene view. So up here you have a scene view. We can just drag it and drop it next side to our game view like this, and we can try to move the player with this axis here. So when I will select it, all this square here, I can move the player around, and you can see the camera is following the player. So that's the other thing that's in this project. This is achieved with a follow camera script. When you will click on the main camera on the left side, you see on the right view here, you have a follow camera script. You can check this script out if you want to see how it is implemented. It's a very simple one. Okay, so we want to have now point to click a movement. So when I will click on some space on my map here, when I will play the game and I will click somewhere on my map, I would like to move the player to this spot. Another rule we would like to get is when I will be in middle of the moving, so I will be moving, or I will be doing some movement, we're going here, and when in middle of it, somewhere here I will be here, I will press the shift key, I want to stop the movement. So shift will be stopping the player, and while the shift will be pressed, I will be rotating the player. So when I will be moving my mouse while pressing the shift key, I will be able to rotate the player in the direction of the mouse. Okay, so I will click here, I will rotate here. If I will click here, I will rotate here. So that's the basic rules we want to have. Click at the point, move there. When pressing the shift key, stop the movement and just keep rotating to the mouse position. Okay, let's implement this. Let's stop the game. Let's create here a player controller. So click on the player. All right, click here Add Component. We call it player controller, like this with the uppercase P, player controller, like this. You see, we don't have the script, so we need to add a new script. So new script here, player controller, verify the name and create and add. Okay, so this should add a script to the player. We'll see on the right side we have a player controller. Click these three dots, click here edit script. This should open your coding editor, and it should open this script. Okay, it's not opening. I need to go manually to Visual Studio Code. I need to do here some changes because I just been doing something with the GitHub, but here we should have a player controller. See, here is player controller. That's what we have created, but it's in the default folder. It's not in our game SRC folder, which I prepared for you, and I want to have all of the scripts in this script folder. So what we will do, this player controller you have here, you will just drag and drop it into the scripts folder here, and you will click here move. Now you have a script in your player controller, in your scripts folder. Okay, verify that everything is good here, and it should be. So when you will play the game, nothing, you shouldn't see any error, nothing, and everything should be as it was before. And now you have a player controller on the right side. So now we can edit the scripts and we can add this movement. So let's get into the script and we'll be coding a lot now. So these comments here I don't need. I just want to remove them, start, and also this will remove, and also this. All right. And we'll go to update. So we want to handle a couple of things in the update. So when I will press the shift key, I want to stop the movement. So I'll write here if statement. If I'm pressing the shift key, how can how can we get it? That we're pressing the shift key through the input. So right here, input, and get key, and you are looking for the shift key, so you need to look for a key code and a shift. Left shift or a right shift. It's up to you. I will go with the left shift. Okay, so in this case, you would like to stop the movement. So let's call here function stop move. We want to stop the movement, but we want to still compute the rotation, as I told you. We want to still rotate towards the target. So right here, compute rotation. Of course, I don't have these two methods, so I need to implement them. So I'll hover over quick fix and generate method stop move, and also for compute rotation quick fix and generate method compute rotation. Of course, you can create these methods manually by writing them, or just hovering over the method and clicking quick fix and generate method. Up to you. You see here we have here not implemented exception. We can just console log, debug log here something instead of throwing exception. So debug log compute rotation. Okay, and in a stop move, we would like to do the similar thing. We would like to call here stop move. Okay, so we have these two methods. They are not doing anything, but we at least have we are detecting that we are pressing the shift key. Okay, now we'll write here else if. Okay, so else if, like this. So what should be the second condition? So second condition will be that when we are pressing the mouse, when we are holding the left mouse key, then we would like to move or compute movement. Okay, so let's handle this condition. So let's write here input and get key, and we are going now for mouse button key. So you're not getting it with the get key, but you have a specific function for it. Get mouse button, and you are looking for a specific button. When you're looking at the button that is index 0, this is your left mouse button. Okay, so now we can handle the second thing here. When we are pressing the left mouse button, we would like to compute target. And again, we need to implement this method. So I will just hover over quick fix and generate method, and we have a compute target. And we'll do the same thing. We'll write here compute target. Okay, so recapitulate. When we are pressing the shift, we are stopping movement, but still computing the rotation. When we are pressing the mouse button, left click, we want to compute the target where we want to move at the map. Okay, now we will create a couple of variables up here, a couple of new fields. So we need to first we will be keeping the track of the movement, and we will be adjusting it by speed. So the speed will be, the higher speed will be, the faster will be moving. So we'll create here a new serialize field, and it will be private float, and we'll call it speed, m_speed. So I'm prefixing my fields by the m underscore when they are private. So they're saying they are member fields. That's just my convention. And the base speed will be 5f. Okay, so 5 units. Then also similarly, we'll have also declaring how fast we want to rotate toward the target. We'll have also rotation speed, and this can be, let's say, it's faster, it'll be 10 units. Then we'll create here a new private. This will be not serialized field, but it's a private one field, and it will be the point where we would like to move. It will be vector 3 point, because we'll have an axis, we'll have a position x, y, z, so that therefore vector 3. And it will be calling this move point, and move point will be computed directly here in compute target. When we'll be clicking the left mouse key, we would like to compute this move point. Okay, so vectors are structs, so they cannot be null. If you would like to make the struct null, so the default value will be null, you can write here this question operator after the type, and you can now declare it as a null. So default value for the move point will be null, so we are not clicking. Okay, now we need to also know when we'll be moving, what direction the player is moving. For this, we'll create a new vector 3, and it will be direction. So m_direction, and it will be by default vector 3, 0. Okay, so we are not moving anywhere. And by the way, this vector 3, 0 is by the default when a direction is created. So we don't need to write it. Now, we'll be writing also rotation. So that will be the target rotation to the rotation to which we want to get. So we'll write here private quaternion for the rotations. Quaternions are for rotations, and m_target rotation. Okay, I think we have everything we need. So this is the first important thing is a move point. So we want like to, when we'll click at the mouse, with the mouse in our field, on our game field, we would like to get this position. So when I will start playing the game, my player is at position, and you will select the player, and you will see on the right side the position where the player is a 0, 0, 0. When I will click here with the mouse, let's say I will be clicking here, I would like to compute this move point, right, in the coordinate system. So we know that our player is 0, 0, 0, is our default location. I would like to move here, so when I will click here, I need to get a location vector tray of this position. Let's say this will be 2, 0, 2. I don't really know. But when we will this, it will be assigned to the move point, and will tell the player to move here. So we'll have a move point, we'll compute the direction of this move point, and we'll move player in this direction. Okay, so plan is clear, so let's do it. Back to our code. We will go now to compute target, because in the compute target we'll be computing this move point. Okay, so we can remove the debug log. How we are computing the mouse clicks? You will do it with the raycasting, and the position on the map you will get from the camera. I will show you how you do it. So we can combine it into one call, or we can actually do it in the two. Okay, I'll do it for clarity in two. So let's write here var, or vector tree actually, vector tree, and screen point, and equal, and you can get it like this. You will get a camera dot main, and you will call here a function screen point to array. Okay, and here you will provide your mouse position. So how can you get a mouse position? Again, with the input, you will call here input and mouse position. And this is actually not returning the vector tree here as I wrote here, but when you will hover over, you will see that it's returning something called array. So you're getting array type here. So this should be really array. If you want to imagine it, how it is, how this array looks like, what we are trying to achieve here is you can see now. I will go to Unity, and here we have our camera. All right. So let me see the camera. I'll go to the scene view. Okay, so scene view and camera. In the left side you have a camera. You will double click it, so you can see the camera actually where it is pointing. All right. So it's pointing in this direction. Here is a camera, and here we have a player, right? And what we are doing when I will be clicking the mouse on the ground, or actually it doesn't really matter when I will click the mouse. It's casting the array from the position I'm clicking on. From the camera. So we'll click here, let's say, and this will cast the array here. And then we'll be using raycasting, and we'll getting the position, the actual vector tree here, and we'll be assigning it to the move point with the raycasting. And we'll be just checking positions on the ground. Okay, what is the ground on our map? Is this ground that we are standing on? So this is ground here. When I will select the ground, that's the ground. This is the ground. We'll be checking the positions here. So we'll be doing raycasting. Currently, we are getting the array from the camera, the clicked position. Okay, so now the raycasting. Let's get back here. Okay, we have a screen point, so now we'll use the if statement, and we'll be using the raycasting. Raycasting you will do with the physics. So you will access your physics, and you will call here raycast. Now, in the raycast, you need to provide a couple of values. One of them is a screen point, or screen, I should call it array. Screen array, like this, and we'll be providing the screen array. Now, the another thing will be the output, what you will get here. So output array, and this will be the raycast hit. So it will be the hit position. So we'll write here raycast hit, and this will be hit. So this will be the output from this. If we'll cast the raycast and we'll hit the ground, in the hit here, we should have actually vector 3 positions, the spot we are hitting. Then the length of the array, so that maximum distance the array can go. Let's say 100 units. And then one last value will be the layer mask. You see here, we need to provide here a layer mask, and that will be the mask, the layer of our ground. Let's keep it as this, and go to Unity, and then you will select the ground. You see on the ground here on the top, you have a tag, and next to you have a layer, and currently selected the floor. You see? So this already was done in the project for you. If you want to create the layers by yourselves, select the game object, and in this case the layer, and click here add layer, and you can add here any layer, so whatever, it doesn't really matter. And I can go back to the game object now to the ground, and I can select the layer whatever. Okay, so now this is layer whatever. And of course, we want to call it a floor, not a whatever. So let's go, please, back. Let's select the floor. So now this ground here, this game object you see here, is now in the layer of floor. Okay, perfect. And now we will get back to our code, and we'll create here a new serialize field, and we'll create here a private and a layer mask, and we'll call this floor mask, like this. And floor mask we will provide to here. So that's what we would like to detect collisions with for our array. So we want to hit only the objects of floor, not any other objects. Every other object will be ignored in the array. Okay, so brackets. We'll be casting now the raycast, and if statement, if we'll hit the floor, we'll get a position on the floor we are hitting. Okay, we can check it out. We can write here debug log, and as I told you, in the hit we have a position, so you will access here hit dot point. So that's a point you'll be clicking on. Okay, now save this. This will recompile very shortly. Please select the player because we need to do one more thing. Go to your player game object, and on the right side, even the floor mask, you see we need to select your floor. So please go ahead and select your floor this way. Actually, I was doing this in the play mode, so when I will stop the game, it will be nothing again. So make sure you're not playing the game. And again, now we select the floor, and now we'll play the game. And when I will click on the floor, we should see the position when we are clicking on. So when I click on the player, somewhere close to the player, you see the positions are very small. You can see I cannot click directly on the player because the player is not in the floor mask, so it shouldn't detect anything. But when I click very close to the player, you see I'm getting very small positions, around 0. Okay? When I will click on somewhere on where is the enemy, so here I'm getting positions like 595 and 884. So you can see we are reaching quite far. This should be the player. This should be somewhere the enemy position. But let's try it out. Let's click somewhere close to enemy, and very close. And position is the 548 and 895. And I will select the enemy, and you can see it's indeed it is very close to it. So enemy position is 555 and 973. So indeed we are clicking very close, and the positions are correct, and we are clicking on the map. Perfect. So now we have done this step, we can shut down the game. Go back to your calling editors, and let's finish this implementation. So we don't need to debug log it, but instead of this, we can assign it to their move point. So let's write here m_move point, and we can assign here our hit and point. That would be good in most of the cases, and in our case it's good because our ground is really flat, and our ground has a position. You can see the y position is 0, so the y coordinate will be always 0. But if you have some ground, maybe some ridges in the floor, or maybe some valleys, some mountains, and all of this, the y position will be not always null. But in our game, it is null. Okay, so if we would have some ridges or some mountains, we would like to reset the position of the y to 0. So we will get only positions x and the z, and the y will be always 0 on the map because we are not caring about the y position. So I have prepared here very simple vector extension. You can see here, when you will use this method with the new y, you can create a new vector where the x position and z position is the same, but you can just declare the new y position. So I will show you how to use it. So instead of just getting here a hit point, you can just write it this way. I will show you new vector tree, and hit point x for the y 0, and hit point z. So I'm creating the new vector where I'm resetting the y position. I just care about the x and z position. And with my extension, you can use it. You can do it like this. You can just write here hit point, and here you can call this method with new y, and then just declare here y position 0. And this will just basically do the same thing as I just wrote you before. This will create a new vector tree where the x and z position will stay the same, and here you will just change the y position. You can change it to 10 or whatever. In this case, we really want to have it 0. Okay, enough of this. We have a move point. That's perfect. And now we want to get a direction. direction from the player. So in this case, here is the player, right? Here is the player, and here I'll be clicking. So this is the point P. Here is the player PL, and we'll have to get a direction here. So how get a direction? Direction is very simple to get. This is just a subtraction of move point by the point. Okay. So the direction you will get like this. So m underscore direction, and this is your move point minus player position. So get here move point, and since we have get the move point is a nullable type, so we have this question mark next to the move point. The value to get the value, we need to access here value like this, and minus transform position, and also we'll be resetting the y position of the player. So we'll write here with new y, and we'll reset position of the player to 0. Okay, so that's we are getting in the direction to the move point. So move point position minus our player position will get you in direction, and the rotation m target rotation you can get like this. You will get a quaternion and look rotation, and you'll just look rotation in direction, and this will get you rotation in which you need to rotate. Finally, this is your compute target method completed. So you will be clicking, you will be getting direction and also rotation. Perfect. Now we can go back to our update and we can continue here. So another if statement. So now if we have a move point, because the move point can be null, but if we have a value, now we want to move. So you'll write here, if we have a move point, so move point has a value like this. So we have the value of the move point is not a null, but it has some coordinates, and we'll check the distance also. So we'll be checking the distance of our player to the move point, and the distance must be greater than some small threshold. Only then we want to move, because when we are very close to the move point, we would like to stop, because we will never reach the exact position of the move point because there are some small differences. So we'll be going very close to the position of the move point, and that's why we'll be declaring this threshold. So we'll write here vector 3 and a distance. All right, and we'll be checking the transform position. So our player position, so transform position, so that's our player position, and again with new y, and here 0. And actually, if you want to go do it in the two steps, so it's easier to read. We can just copy it, remove it, and up here you can just write here var and the player position. So this is our player position. So we want to get the distance of the player position and our move point value. And if this distance is greater than some small threshold, let's say 0.05, only then we want to move. Okay, so if we have a move point and the distance to the move point is larger than 0.05, only then we want to move. So we'll call here now method move and move. Of course, we don't have this method yet, and we need to create it, this method. Okay, but if we don't have a move point and this statement is false, then we don't want to move, but we want to rather stop move. So stop move. Okay? So now we just need to implement move. So quick fix and generate method move. And now we have here move method. Okay, now let's start working on the move method. So first we'll be computing how fast we want to move, and how fast we want to move we have speed for. But the speed is not, we cannot apply directly speed to our position of the player, because the player will be moving too fast. So what you will do, you will create here a new variable and you will call it step speed. And step speed will be your speed multiplied by the time, delta time. Usually this values as a speed and rotation and this kind of stuff, you're always applying delta time to apply the value to the target, to the player position or the rotation frame wise. Okay, so all these values, the speed you will not be applying directly, but always you want to multiply them by time delta, so you are scaling them down. Okay, now we create a variable movement. And movement will be just simply our direction. Again, we'll be normalizing it. Not again, but first time we are normalizing something. We'll be normalizing it and multiplying it by the step speed. Okay, so we have our movement vector. So that's basically a direction multiplied by the speed. Okay, direction, normalizing the direction, because direction, when you're moving diagonally, direction vector can be larger than when you are moving horizontally and vertically. By normalizing it, you are basically, if the magnitude of the vector will be larger than 1, you are always shrinking it down to 1, and you are keeping the same by keeping the same direction. So if you are moving the diagonally, let's say, so this is your diagonal direction, and magnitude of this vector is larger than 1, what you're basically doing is you are lowering this vector, just making it smaller, so its magnitude is maximum 1, but the direction will stay the same. That's basically what normalization will do for you. And then we'll just multiply it by the step speed, so we'll just scale it a little bit up, so we will be applying the step speed, so it will be a little bit larger. Okay, and then we will use the character controller that we have on the player. I'll show you here, we have a character controller on the player, and we will be moving with the character controller. First, we need to get the character controller, so we'll go up here to start. We'll create here a new private field, and we'll call it character controller, m_controller. Or you can call it character controller. Character controller, and in the start we'll get it. So m_character controller and get component character controller. Okay, this will get you character controller. Now we have it. We can go back to our move, and we can move. So we'll write here character controller and character dot move, and we'll provide here a movement vector like this. Now let's save this, and we should be able to move. So let's save. We don't have a stop move functionality, so we should be keeping moving quite a lot. Let's save. Let's run this. So let's until recompile. Let's play the game. Click at the position, and you should be moving in the position. Okay, we are also stopping moving. Perfect. Okay, so we'll move, and then we are stopping movement. You see that we don't have stop movement functionality really implemented, but it's okay because the stop move functionality will be basically for the animation. We don't have animation yet of the movement, but we will be implementing it. But yeah, so far it works good. We are moving. We are also stopping movement. If you want to now rotate to the movement, what do you need to do? Go back to your code, into our move. So here we have a movement, and now we will be doing the rotation. So rotation we will do like this. We will write here transform rotation, and now we have our target rotation. But if you assign here directly target rotation like this, you see what will happen now. We will be snapping to the rotation immediately, which is not that great. Let me show you. It will look like this. Okay, so I'll just simply snapping to the rotation. Okay, maybe that's something you want. Maybe you want really fast rotation, and this works definitely okay for some games. That's fine. But if you want a smooth rotations, for smooth rotation, you will use the lerping, which means linear interpolations, and you will do this. You will access your quaternion, slurp, spherical linear interpolation. What is this? This is what this means, and you will go basically with the lerping. You will go with your rotation which you're currently in. So you're currently in a transform rotation, and you want to go to the target rotation, but you will be not snapping there, but you will go into some intervals there, and you will use your rotation speed. So m_rotation speed multiplied by the time delta time, and this will smooth it out. Okay, so that's how you'll do the rotation. So you're going from your source rotation, which you are currently into the target rotation in these small intervals, whatever value here is the rotation speed multiplied by the time delta. Okay, and now when you will play the game, okay, you shouldn't be snapping anymore. Okay, so nicely rotating to the target and not snapping there. Okay, so we have all of this. But what is missing in our game, as you can see here, is our movement we have, but we don't have any animation of the movement. And also one thing I noticed, when you will do the movement, you move and press the shift key. Nothing is happening. We are calling here compute rotation. But what we should do, what I tell you, when you will be moving somewhere and you will press the shift and you will be holding it, you should stop the movement. And that's why we actually have a stop movement as well. Okay, so let's implement this shift key to stop movement, and then we'll focus on the animations. Okay, so let's stop this. Get back to our code, and we'll go into stop move, because here we are calling it when we are pressing the left shift key. We want to stop the move. So let's go to stop move. Here we have a debug log stop move. Of course, we need to do here a couple of changes. To stop the movement will be very simple in the middle. Just access your move point, and just assign null to it, and that's it. And also tell your character controller to move like this, and just provide your vector 3 0. So that's right here. Actually not like this, but the vector 3 and 0, so no movement at all. Okay, let's save this. Now when you will go to the game, and we'll declare the movement, so we'll click somewhere on the map, and in the middle of this we'll press the shift key, then we stop the movement. So let's click somewhere on the map, press the shift, and we are stopping. Going there, pressing shift, and we are stopping. But the one thing is, when I will stop now the movement and holding the shift key, and I'll going with my mouse around, you see I'm not rotating to the mouse direction, so we need to fix it. And that's what we'll be using for will be compute rotation. So when I compute rotation, we'll be computing the rotation to the mouse position even when we are stopped. Okay, so now go to your compute rotation. Actually, we can copy from compute target this ray, because we'll be doing the raycasting again. So we'll be pasting this here, this part, but the if statement part will be changing in the compute rotation. So what we'll be doing here, we'll be getting first the direction. We'll be computing the direction to the point what we are clicking on, and I told you how you can get this direction. So that var direction, and that's your point subtracted by your position. We'll do it like this: hit point with 0 y position minus transform position with the 0 y position. This will be the direction. So the hit point, okay, hit point minus player position. Now we have a direction. We can compute here target rotation. So m_target rotation equal quaternion look rotation into the direction. Okay, direction, and here will be simply computing the rotation here. So this we can up here we can use this spherical linear interpolation, and go down here, and we'll paste it here. Okay, so yeah, that should work without any changes here. Let's save this. Okay, and let me see, we are calling the compute rotation here. Yeah. Okay, so let's save this. So as you see, when we are pressing the shift key, we are stopping the movement, and we will be computing rotation to the mouse position. Let's play this, and let's see. Okay, let's play. Let's go somewhere to any position we want. Press the shift key, we are stopping, and when we're moving the mouse, we are moving into the mouse position. When I will stop the pressing shift key, I am not moving to the mouse anymore, and I can click here, and again shift, and I can move into direction. Okay, perfect, because that's what you're doing in these top-down games, right? In most of them, you are navigating by the pressing on the map, and when you press the shift key, you're stopping the movement, and then you can target the enemies, and you can rotate towards them. Okay, so now we have this, but now about animations, how we can handle some animation. When you will click on the player, and the player you have a controller, and you have here a soldier animation controller, double-click it, and this is your controller that's playing your animations, and you can see that default animation in this view is idle. When you will click here idle, this animation is playing, this motion on the right side you see, that's the motion we are playing. So when you play the game, from the entry you are going to idle, and that's the default animation you are playing. Double click this, or just click here on this idle here, you see nothing happens, but because you on the top here in the bottom here, you need to click on the project view, and then you click in this clip here is motion, and this will select this motion down here, and you click it again, and here is this motion, this is the idle. See, that's the idle animation. And here we have more of them. We have a charge. When you will select the charge, click here on the charge and play it. This is the charge clip. Okay, so how can we select between them? Okay, for this, you can stop this. You can go back to the idle view and simply remove it. So command and shift, command and backspace, or control and backspace, or just right click here and click here delete. Okay, and delete this. Right click here, create state, and from new blend tree. You have here a new blend tree. You can rename it. So in top right, you have a blend tree. You could just call it locomotion. Okay, now we have a locomotion. Double click it. Here is your blend tree. Blend tree means that you can create here multiple clips, and depending on some parameter, you can blend between them. I'll show you what this means. So here, as you have your motions, click here the two new motions, add motion field, and one more, add motion field. And now select your clips, what I showed you down here in the project view here. So first clip, select the idle. So these are the idle clips, and place it in the first motion. Now select your charge clip and place it into your motion. Now you have two clips, and you can blend between them. And also when you create this blend tree, there was a parameter created for you. You can see in the left side, as you have this view here, you have here blend, and it's 0. Rename this blend for, let's say, speed, like this. And now, depending on the speed, you will be blending between these two of them. Also notice here, you have here automatically defined threshold. When the speed will be 0, then you will be playing the idle. But when the speed will be becoming 1, you will be playing the charge. Okay, and also you can see the parameter here is a speed by default. If it's not there, you need to select the speed there. So that's your parameter here. That's your speed here. Okay, if you want to see it in action, just play this. I can play this, and you can see we are in an idle. But you need to first select the blend tree. Okay, so that's very important. You need to select the blend tree and then play this. And now you can change the speed. You can see by toggling this, I'm starting moving. I'm blending to the speed now very slowly, and when I will go to 1, this will be moving. When it will be 0, we are idling. When the speed is 1, we are moving. That's a blend tree. You can blend depending on this parameter. You can blend between these two animations. You can also change the thresholds here. You can see you have automate thresholds selected, and we will deselect it. I can say here that the charge will be already coming, will be playing when the speed will be 0.5, let's say. You can play here 0.5. And now when I will playing this, we're idling, and when our speed becomes 0.5, you can see now it's 0.5, I'm already running. So you can change this threshold as you want, but I'm going with the default one. I will select here back 1, threshold 1, and I will click here automate thresholds, like this. So that's the blend tree. So now we can blend between them. Okay, again, select the blend tree, and with the speed we can control the animation. Okay, so that's how your animator look like. All right. By the way, if you want to move like this, you need to hold Alt key and Option key on the Mac. Now you can go. You can see you're in the locomotion layer. Make sure that you have speed. You have these animations here. Now go to the base layer, and you see that we have locomotion attached to it. That's perfect. We can go back to our scene view. We can play our game, and we should be in the idle by default again. We are not changing anything. We are in the idle. But as soon as we will be increasing the speed, so our player will start moving, then we need to toggle this animator parameter. So what we'll be doing, I will just get the animator. I will drag and drop it next to it. All right, so you can see it. So this speed that we have in the parameters right here, when we'll be moving the player, of course we are moving, so we should increase the speed here also. So when we'll be moving, we'll be increasing the speed to 1. So I will manually select here now 1, and you can see the player is moving. And when we'll stop, I will select it back to the 0. That's what we want to do from the code now. Okay, so let's shut this game down. We don't need any more animator view. We know what we need to do. We need to just toggle the speed as we are moving. So back to the scene view, back to our code, and we'll get here animator component first. So let's write here private animator, m_animator, and we'll get here component. So m_animator equal get component animator. We are getting here, we have now animator. Perfect. And now when we will be moving and stop moving, now we need to toggle the values of our animator. Okay, so we'll be keeping the track of the value of our speed in the animator with a new variable again. Okay, so I will create here a new variable somewhere, doesn't really matter. Let's say under animator, we'll create here a new private float field, private private float, and we'll call it, let's say, movement speed blend, m_movement speed blend. So this will be the value we'll be assigning to the float, and this will be the value we'll be assigning then to the animator. Okay. Okay. Now we can go to the move. So we need to now toggle this value of the movement speed blend, because by the default the value is 0, but as we'll be moving, we would like to increase this value to the 1. So how to increase this value slowly to the 1? To increase something slowly to the value, you will be using again linear interpolation. Okay, so we'll access this value m_movement speed blend. We'll use here lerp, so we'll be just using it as a simple lerp, which is you can access on the matf and lerp method, you can call it. And you are going from the current value of your movement speed blend, which should be 0 in this case, and you want to get it to 1. Okay, and the increments of this value will be step speed, what we have defined here. Okay, so now we are assigning the value. The value should be increasing slowly to 1, but we are not assigning it to the animator yet. So what we will do down here, we'll access the m_animator, set float, and we'll access here the parameter from the animator. How we are calling this parameter in animator? We are calling it speed. Make sure it is uppercase as the same written as in our animator. So maybe you want to double check, go to animator, and you want to see the speed here, and it should be the same. So here speed and the value you want to set it to, and it will be your movement speed blend like this. Now you need to save it, go back here, you can play the game, and you will see you will be already moving. Play it, and when I will click here on the map, I'm starting to move. I always was moving, but and I'm playing this animation. When I will stop, I'm still moving. So now we need to decrease this value, and we need to set the value when we are also stopping the movement. So stop this. Go to your stop move, where we have it. Here is the stop move, and here we want to stop. So again, we will access here m_movement speed blend. Again, we'll be lerping here, math f lerp, but now we are lerping the opposite direction. So now we want to go from the movement speed blend current value, which should be 1, and when we are stopping moving, to 0. We want to decrease it again by some time interval. And here in this case we don't have this step speed, so we can get the step speed by delta time multiplying by the m_speed. Okay, and then again m_animator and set float, and you will be setting the float of value of your parameter speed, and value will be m_movement speed blend. Okay, and I think we should have everything implemented. Let's save this. Let's get back to our Unity. Okay, let's wait for recompile. Let's play the game, and when I will move, I should be also stopping. So when I will click at the point, I'm moving to the point, and I'm stopping when I'm reaching the point. Moving and stopping, and I will go somewhere, I press the shift, I'm stopping immediately, and I'm rotating to the target position, which is working perfectly. Amazing. So I'm stopping, moving, and while I'm holding the mouse, I can also move, and like this, it works great. Okay, so here you have it. Simple, very simple player controller, which works for these top-down games. You can see not more than 90 lines of code, and everything should be at this point very clear. If you want to do some changes or you have some questions, you can ask them in the comments section. Also, if you want to change the values and adjust them, go ahead. Just go to the player. Oh, you don't need to go to player, but you can play the game, and you can select the player and change these values while you're playing. So let's say I want to faster player, I will get a speed to 10, and then the player will be much, much faster. And you can even decrease it, increase it even more. Rotation speed maybe 20, and now you'll be rotating much faster. It will be more reactive, you see. So maybe that's something you want, and I will keep these values to adjust for you as you want. And remember, when you are changing the values in the play mode and you will stop the game, it will go back to the default values, so you need to change them in this mode now. Again, so that's there you have it, player controller, and that's from this video. You find the code and the entire project always in the comment sections. See you next time.